Recording. Good morning, good evening, good afternoon. It depends on from where you are joining the program. Welcome to Big Bang Data Science Solutions Ramadan program. And today we are going to do week number 4. So in week number 1, we talked about the data explosion. We talked about data science in general. We learned about analytics type, the career in data science. What is data science? Is data science for me? Then, of course, we built a foundation on Python. So we learned about the Python in general. Then we learned about the 6 most common Python packages. We learned about NumPy, Pandas, Matplotlib, Seaborn, scikit-learn. And then we learned about the crisp DM, or the first phase of the crisp DM. We learned about the business understanding in general. So basically, we talked about the how to frame a problem, how to start, how to extract interesting questions from the business problem or the business statement, how to identify your analytical approach, how to build a strong relationship with your stakeholders, how to build an analytical team. And then we moved into reading the data, and we transformed the ABT, the analytical base table, into features. Then we collect the data, we gather the data that we need, then we read the data into Python, and we start playing around it. So today we are going to spend probably today and tomorrow on understanding the data. So this is what we covered so far. We talked about business understanding, where we'll be relying heavily on our domain expert and business expert to help us go through this phase. So we learned how to determine the objectives of your program, the project that you'll be working on. We learned how to frame a problem and assess its feasibility. We learned how to define the business measurement. Then we learned about the target variable if we were to do predictive analytics. We learned how to identify an analytical approach. We learned how to identify a deployment plan if there isn't any, how to produce a project plan, start date, end date, and deliverables. And also we talked about the stakeholders and the team. And finally, we talked about the analytical base table. Then we transformed the analytical base table into features. So we moved into the second phase, which is data understanding, where we rely heavily on our data expert. So this is the person who can help us transform ABT into features, collect the data. Data could be anywhere. It could be different servers. It could be scattered across many resources, in many format, in many shapes. So we collect the data. Then after collecting the data comes here in a row shape. Data comes in a row shape. Simply means it could be anything we are looking for. It could be little data. It could be little data. It could be data with so many problems. But anyway, it's a raw data. It's not ready yet, regardless of how good it is. It might not be ready yet for an analysis. So we read the data to after installing packages needed. We read the data into the platform, in our case, into Jupyter Notebook. And now we are going to put some effort to understand the quality of the data by simply manipulating, wrangling this data, applying some exploratory data analysis, EDA for short, doing some data visualization and statistical analysis. Towards the end of the day, we have to design what we call the code book or quality book. This is the book. It's a technical summary. The quality book is a technical summary of how good or how bad your data is. So it's simply, it summarizes anything, everything that you discovered on your data when you applied the ADA, data visualization and analytics, in terms of errors, duplicates, and missing values, outliers, categorical transformation techniques, etc. So this is the book. This is the book we are going to use, for data preparation later. So this is what we need. This is what we need to design by simply going through our data using any of these technologies, any of these concepts. Manipulation, ADA, data visualization, and statistical analysis. We already did basic statistical analysis. Like we use the info function, we use the describe function, at least to help us understand basic things about our data. Yeah, that is the plan. Today we are gonna apply some ADA, data visualization, and we are gonna take it very slow. So hopefully, by the end of tomorrow session, we should be done with quality book. Yes, sir.
Just to frame ourselves from the last weeks, what we develop as a matrix or the table that when you do function like bank apps dot head, is that the example of analytic based table ABT, or
No.
what is that?
The ABT is simply a table describing what would you need as far as the data is concerned.
Is that a CSV file then?
No, it's not. I mean, you design it the way you want. It tells, it identify the major or the major concept from data, conceptual data you need. Let's say that you are working on our insurance and you have a lot of data. Okay, after you discuss internally the problem statement with your team, you framed it. You thought that you are going to need data from claims. So you are in your ABT, you should say we are going to need claims data. We are going to need clients data. You are going to need payment data. We are going to need policy data. And our target variable is going to be a claim. Is it fraudulent or not fraudulent? That's all where you need to do that. That is ABT.
Okay,
Not,
so
not,
the
not
the
the data. It's not data. It's simply explaining to the management, explaining to the entire team what exactly you are going to need as far as the data is concerned.
okay, so your CSV file, was this an example of collect initial data?
Uh, no, yeah, yeah. Let's design ABT together. Okay. After you went through uh, business statement framing, this is what you should come up with. So what do you need as far as data is concerned? Fraud, we are going to need, let's say, yeah, we are going to need here, we are going to need here client. Okay, we are going to need here, let's say payments. You are going to need here policies. You are going to need here claims. Okay, and of course, of course, you are going to need, since it's a binary target variable, binary problem, you are going to need, is it fraudulent? Fraudulent, yes or no? Yes, no. Okay, so this is a very simple ABT. Okay, so we are going to need claim. Uh, we are fixing a fraud claim or trying to predict a fraudulent, the status of a claim. Then this is what the data we are going to need. Conceptually, this is what we are going to need. Okay, we are going to need data from client, and we are going to need we are going to need data from clients. We are going to need data from payments. We are going to need data for policies, claims, and yes or no. And under client, we are going to need let's say we are going to need demographics. Okay, demographics. And under client, we are going to need demographics. And of course, under demographics, we are going to need few things. We are going to need here age. We are going to need marital status. We are going to need education level. Okay, so this is what you are going. This is an ABT. It's simply describing from the conceptual standpoint what you are going to need as the data is concerned. And you did the same for payments. You did the same for policy claims or for something else. But this is what we call an ABT, and you could design it the way you want. As far as it contains all the information you are going to need in terms of the data, that'll be fine. Then finally, when you have this ABT, then now you are going to transform the ABT into features. Now we are going to have an ABT, and we need features. We need to transform into features. Now give me the data. So the data could be, everywhere. Let's say probably this data is, this data here is in flat file. Flat file. This is flat file. This is server one. This is something we are going to scrape from a website, HTML. No, we don't have this data. Probably we have a data which is going to be, let's say this is JSON, and we don't have this. No. So this is so as you see here, the data is scattered in different resources and probably in different format. So we need to read all, we need to collect all this data and start putting it all together. That is what we're supposed to do. When we're trying to transform the ABT into features. So we are going to get the data in many format, in many shapes, from many resources. We could read all the data into the tool, and we start merging the tables, transforming a format to a different format. And once we have it in one file, then we start trying to start putting effort to learn about its quality by applying data manipulation, ADA, visualization, and statistical analysis. Okay.
Very clear. Thank you very much, Mo. I think it's very clear now.
Yeah, welcome. Anyone else? Anyone else having any doubt about ABT?
Sorry, Brother Mohammed.
Yes, sir.
Can you do the same thing for the code book? Because yeah, what you just explained is very clear right now.
Yeah.
Because I thought it was a table.
Yeah, I mean, you could design it. You could design it any way you want. All I care about, what is what from the conceptual standpoint, what do
Mm.
you need from me as the data is concerned? That's all we need. And
Yeah.
this is designed up. This is a brainstorming. After, of
Mhm.
course, you discuss this with your internal team. Your data expert is involved, your domain expert is involved, data scientists, analysts that are involved, your manager is involved, and your business expert is involved. You cannot come up with something like this unless you have everything, everyone involved, covering the problem from different corners.
Mm.
As far as the quality book, that is what we are going to learn. So we are going to learn about the quality book later.
Okay.
For now, just let's apply some. Let's learn about the quality.
Okay. Thank you.
Of course, we are going to design a quality book. I'll give you a very simple example. Yeah, I have one here, I believe, all the way to the bottom. Here we go. This is an example, and yeah, you could design it. You could design it the way you want. It simply talks about, I mean, the structure of your data, where the data is being collected, how do you connect to your data. Talk about the variables, univariate, bivariate, multivariate data, etc. Talk about the summary, the type of the variables, the range, the missing values. Talk about the numerical values versus factorial factors, latent variables. Talk about the central tendency, the distribution, the skewness, the measurement of variability, standard deviation range. Talk about the relationship. That's, I mean, so it could be different from one scenario to another, but just try to collect as much as you can in terms of the technical quality of your data. Yeah, try to unfortunately, the machine learning in general is a GIGO. Yeah, machine learning is a GIGO, means so machine learning is what we call GIGO. And GIGO simply stands for garbage in, garbage out. It is what the GIGO stands for. So it's garbage in, garbage out. Means if you miss something on your data, let's say you have missing values and you did not see it, or you have a typo in there, or you have any discrepancies in your data, and you simply did not catch it, or you did not learn about it through your ADA, data visualization, statistical analysis, most likely you are going to design a garbage solution. So all this effort is simply, we want to avoid the GIGO concept. We want to make sure that we are feeding a high quality data into our model to ensure the high quality output. So this is called GIGO, or GIGO, or whatever you call it, but it's GIGO. Garbage in, garbage out. So all this effort that we are trying to put into our data, learning the data, is simply trying to avoid the GIGO. Yeah. So ADA, data visualization, statistical analysis, is to avoid the GIGO. Okay, Fali, clear?
Yeah. Good. Thank you.
Yeah, welcome. Any other concerns, questions, everybody? Everybody, any concern, any doubt? Okay, I'm gonna carry on. Hopefully, you guys, you are clear about it. So let's go back to Python for short enough for now. Yeah, I'm gonna start. I'm gonna clear the output and start the kernel. So we've been hired as data scientists, and we are working for a bank, and we're simply trying to determine if a client will purchase a term. That is all we're trying to do here. So we were provided by a data dictionary. It's simply a metadata of the data itself. It describes the variables. It describes the data that we have. So the first thing that we did, that we imported the basic packages. We imported the NumPy for numerical Python, a Matplotlib for data visualization, Pandas for data analysis and data manipulation. Then we imported Seaborn, which is an advanced package used for data visualization. And then we set the column into max, because sometimes if you have many columns, you might not be able to see them all. So you see the first 10 and the last 10 of your data. And to avoid that, we could set we could change the max column to be displayed. So just put a number greater than the value of the number of columns that you have. Then we were able to read our data using the read CSV, which is a pandas package, a pandas method. It's a PD pandas method. What is PD? Is import pandas as PD. So it's a pandas method. This read CSV is pandas method. Yeah, if you were to yes, this is if you were to always good for a package that you are using and you are not familiar with, just Google its documentation. So I'm googling pandas, and this is document is 33,000. Is 3,300 pages. It's huge, but this is your starting point to help you understand basics about this great package. So there's a lot how to let's take a look. Okay, let me see. Okay, so how to merge, how to group, how to reshape, talks about categorical data, plotting. Yeah, please use this and play around it. Yeah, I'm gonna share the link with you guys in the chat for those who are Python starters. And if you scroll all the way down, probably you're gonna see a lot of examples. So this is probably you should start with these pandas. Go through this. It might take you a month, but it worth the effort. It will explain everything you need about this great package. Go through that. A lot of examples. Simply copy these examples. Like for example, copy this one. Okay, just copy this one. I'm going to show you how to do this. Go to your pandas and just create a new file. There we go. And just name it understanding pandas under. Okay, and paste, run it. Okay, so we are going to import pandas number one. Let's import pandas. Import pandas PD. There we go. And now let's take a look into PD. There we go. So this is how you learn. This is how you would learn and play around this. Yeah, please do that. That is your homework for the entire 10 weeks. This is your homework. Simply go through the pandas library. Just take pandas out of your plate. Lot of examples. Take a notes. play around it, break the codes, play around them, see if you can design something for the see if you can apply some of these methods and functionalities on the bank data. It's a lot of beautiful graphs you could build, a lot of data visualization, a lot of things that you could this now pandas would be enough probably to get you started. So learn pandas. Just take it off your plate. A lot of examples, a lot of just copy, paste, and start playing around it.
Sorry, Brother Mohammed.
Yes.
I was a little bit lost at the beginning. What did you put on the? I was opening the notebook.
It's this pandas PDF, pandas documentation.
And how did you open it on the notebook?
No, it's not. No. It's this is a PDF. This is a PDF. Not.
Oh, this is a PDF. Okay.
Yeah, I shared the link with you guys on the chat.
Thank you.
But what I was saying, go through this pandas and simply copy paste. Yeah, simply copy paste. Copy from the codes, paste them to your Jupyter notebook and play around them. That is how you learn. Okay. Any question, concern about the pandas? But take this out of your plate. Please put some effort. If you are really serious about learning data science, start. This is how you learn. You really don't need to. From my own experience, you don't need to. You can learn data science on your own. You really don't need to pay anyone to teach you data science. You simply need some guidance how to start, and once you pass your the first 2-3 steps, then you are good to go on your own. Okay. Going back to I'm going to cancel this, but I just showed you how you could start using these packages. So we were able to read our data, and let's take a look into the columns. So this is the columns that we have. Yeah, we got some problems with the data, with the column names. As you see here, we got a dot. Yeah, I believe we got another dot here. We got a Y. We got a dot. So we need to simply fix this type of problems before we run into a serious problem later. So we are going to do some rudimentary cleaning by replacing any space with underscore, any hash with underscore, any special character with underscore. And we transform everything to lowercase to avoid duplicates of records. I'm sorry, for the columns. So run this very quick. Then now let's take a look into the head function. The head method simply displays the first 5 elements of your data. By looking into this data, we know there is a lot of work we are going to do. At least from the helicopter view, we have a lot of categorical data that we need to transform later. So the tail, that's the opposite. It displays the 5 last elements of your data. And now we have to start. Now we are going to do something very important here. We are going to rename our target variable. So we want to have a meaningful column name. Y means nothing to us at this point of time. And also the target variable is nominal. It's yes or no. Actually, it's binary. So it's nominal. We have to transform it into -1 and 1 or 0 and 1. So let's take care of the target variable first. So we are going to rename the target variable, which is y, into term deposit, and we are going to change it in place. Means apply the change on the original data set. Let's take a look into the head one more time. And now if we were to compare the previous data, the previous data to the data after conversion or after renaming, now we have the y. Now we have it as a term deposit. So, and we need to transform the value of the target variable into a binary. So we looked into the shape. So we got 41,000 records, almost 42,000, and we got 21 columns. Then we looked into the info. The info tells us the structure of your data, how the data is being structured, which is this is where we should start looking into missing values, and also looking into the type of the data. So we got some objects, and so we got some object here that we need to deal with. Okay, so then we looked into the describe, which provides the 5-number summary of your data. It provides the standard, the mean, the max, the 25%, 50%, 75%. These are extra information, the count, the mean, and standard deviation. But normally, the describe provides 5 numbers. And you, as a data scientist or as an analyst, your responsibility is to go through these features one at a time to make sure that they make sense statistically, and to make sure that they make sense in relation to the domain that you are trying to to analyze. Let's say, for example, if you were to work on a fraud claim, and in the age, you find the minimum is 11. Of course, there is no state. There is no state, as far as I know, that issues the driver license at the age of 11, unless this is your son who simply took the car without your permission. Now he drove the car while you are taking a nap, and he got into an accident. So that is how important understanding the statistical analysis of your data. It helps you avoid the GIGO. If the minimum is 70 is 11, it's a good number. But it's when you apply the number to the domain that you are trying to analyze. Of course, this is a problem. Yeah, we got a problem there. So we need to consult with our team, especially the domain expertise and data expertise, to make sure that there is no typo in there. There is no error when we were collecting the data. So that is how important applying descriptive analytics at the early stage of your projects. It helps you understand the values, understand the quality of your data. Of course, this will help you to avoid the GIGO. Okay, then so we learned about transpose method, simply which change the layout of how you display your statistical summary. I like this format better than the first one. This is just me. You could have a better preference, but I like this one better than the previous one. But it's the same information. You are going to get all the variables in the columns, in the rows, and you are going to get the statistical summary in the columns. So you see here the counts 41,1888 across all the columns. Means we don't have any missing values, luckily, but there are other methods to determine if we have a missing values or we don't have a missing values. And yes, so and this describe, it's simply what it does, provides the 5-number summary for the numerical values. It does exclude the categorical. So if you were to learn about your categorical, you need to add a parameter to your describe. It's called include. You could do include all. The include all will provide the statistical summary for numeric values and non-statistical summary for non-numeric values. But this is a lot of confusion where you try to do the all. So we'd rather split, separate them. So we did by default without any parameters. It will
No,
provide.
can I ask one question?
Yes, sir.
Yeah. So if we have the data, so if data is like a very discrete, if there is a lot big gap in the intervals like age 117, 123, 30, then the result might not be very accurate. So as much as the data which is kind of analogous in the nature, that probably might give better idea or better result. Is that my correct understanding?
I am not sure if I understand your question, Mr. Hari.
Yeah.
Can you repeat your question, please?
Yeah, so let's take the example of age. So like where you have 17, which is minimum, and the 26%, which is around 32 age, and then 50% are around 38, then 75% of 47-year age. So like there is a discrete gap in the like data samples. So if the data is like the information available, which is more analogous in nature, like 17 years of age, 20, 22, 25, 26. If we have that kind of data, then that might give better result when we do analysis.
Right now, we are not doing any analysis. You are right, and that is what we're trying to discover.
Okay.
That is what we're trying to find. Right now, yes, you are thinking in the right direction, and that is why you need to get. That is why you need to document in your quality book.
Okay.
We have a problem. We have a lot of a lot of our clients, they are positions between the 75% and the max.
Okay.
A lot of our clients, they are positions in the middle. That is
so. I wanted to understand from my understanding perspective. We have that kind of a quality in the data. Then, if we analyze, then probably that might give better result. Otherwise, we might end up getting some kind of false result. So when we collect the data, we should keep this quality also in the mind, that how discrete or analogous data
that is true.
quality is.
True.
Okay.
That is true, yes.
Yeah. Okay. Thank you.
Yeah, welcome. So we are going to do we are going to add the parameter include objects, tool, booleans, and characters. And for the describe or non-numeric, you are not going to get, of course, the 5-number summary. You are going to get the unique, the frequency, and the top. So let's take a look of what we have. So we got here, this all the non-numerical values, non-numerical columns, and you see here we got the same count, 41,1888. And for the jobs, we got 12 unique jobs. Marital status, we got 4 statuses, 8 education levels, 3 default, housing, there are 3, etc. Could be the job could be a concern, and the month is a concern probably, because if you were to transform this into numeric using dummy variables, so you are going to create so we already have 31 features. So we are going to create 31 plus 12 plus 11 plus 3 plus 7 plus 2 plus 2 plus 2 plus 1 plus 9 plus 4 plus 3 plus 2 plus 1. So we could end up having, we started with 31 features, and now we end up having 70 plus features. So we might need to reshape the job and the month. Just from the helicopter view. Okay, so for the job, the admin is the most common job, and we got 10,444 out of the 41,000. So yeah, we know we have to transform all these features into numeric if we were to use an algorithm later. That is the best practice. Then we looked into the target variable. It's we got 36,548 from the historical data. They have a no, and we got 4,640. They were a yes. So we can visualize it. And so this is our yes and no. This is our target variable, and this is what we are trying to analyze. That is what we're trying to learn. Once we learn the relationship between all input and the target variable, of course, we are going to use that thing that we learned to apply it on any new clients. That is the plan. So we are going to mathematically, we are going to try to find the mathematical relationship, mathematical influence between all the input and the output. And we are going to try to determine the optimal function that maps the mathematically the inputs to the output. And once we identify this function and improve it, optimize it, then we can evaluate it, assess it, and evaluate how good it is on a different data set. We can definitely apply it on any future data. Okay, so one things that we gotta do here, we are still have in the target variable, it's no, it's zero, no, yes and no. So we are going to transform that into either -1 and 1 or simply 0 and 1. Okay, so yes is going to be a 1, otherwise it's going to be a 0. There we go. And now let's take a look. So now we got more zeros than ones. Okay, so all what we did so far is very simple generic methods to help us understand the data. So what did we learn about the data so far? So we learned that it's 41,188. We learned it's 21 features, 21 columns. We learned that we have some objectives. Objects means that we need to we have some work to do. We learned that there is no missing values, and of course we should go through this one at a time, and we don't have time to do that. But we learned that for age, I think it's the minimum age that we have is 17. The maximum is 98 as far as the client's age, and we could apply the same on all other columns. And we learned that we have some high cardinal features, like job is 12 levels and the month is 10 levels. Others, I think we should live with them. Then we learned that we have 88% of our historical data has been labeled as a no, and 11 or 12% has been labeled as a yes. So this is all what we learned so far. It's all what we learned so far, and you could start document this in a separate file. Question?
So Mo, is this a imbalanced data example now?
It really depends. I don't think it's an imbalance, honestly. The imbalance is something around if we have 99.9 and 0.01, that could be considered an imbalance. I think we should learn something very good about this. I mean, it could be, it depends on the definition of how you consider balance or imbalance. And also it depends on how sensitive the project you are working on. If you are working on, let's say that on a healthcare project where you're trying to predict the effect of a new drug. So this could be probably imbalanced because every very small bias in your result could simply take lives or could kill someone. But we are doing this for a bank. I don't think this is I don't think this is. I think it's balanced. Yeah, I think it should be good to learn a function. So we're trying to learn. We're trying to determine the value of a target variable. A target variable, which is simply is it yes or no, and the target variable is equal to a function that we need to determine. Yeah, a function, that is what we're trying to learn. It's a function of what? Of all input, and all input is age, comma, if we would take some of the inputs. Yeah, marital, education, default, all the way. So this is what you're trying to learn. So you're trying to map all the inputs. This is all inputs to our output or target variable. So once we learn this function on our 41,188, we are going to test it. We are going to test how good it is. So we are going to split this 41,888 into 80% and 20%. So we are going to try to learn it first on 80%, and we are going to test how good it is on the 20% before we determine if it's if it's good for production. So this is what we're trying to learn. Okay, so sometimes this function will be biased towards larger. If your target variable is in balance, like 99.99 and 0.01, this function will always be biased towards the larger value, 99.99. So regardless of the output, always regardless of the input provided, always your function will think that the value will be a no, because it's 99.99. So this is the model we are going to design together. Okay.
Hi, Brother Mo. I have a question, please.
Yes, hold on,
So,
please hold on. I had
okay.
someone ask the question. Let's make sure that it's clear before we move on.
Yeah, this is clear, Mo. Thank you.
Yeah, welcome. Good. Okay. Sorry for.
Yes. Yeah. So just wanted to understand. So the yeses and nos, so for each feature or for each column, not each column, but a few columns, they have yeses and nos. So I'm just confused about what yeses and what nos are we counting for?
So that is a good question, and that is how important you start with data dictionary. So you need to spend time understanding your data dictionary first, and it's already been provided. The output is yes. Why has the client subscribed a term deposit or no? So we have 41. We have 41,188 records, right?
Yes.
So, and we need to, we need to go through this one at a time and label them. So records means clients. So we got 41,188 clients in our historical data, and we need to go through them one at a time to and label them accordingly. Label them as either they have a term deposit, or they don't have a term deposit. So 88% of our 41,188 records, they have no term deposit, and 12% they do. Okay, and in these records, what do we have? We have campaign, P days, previous outcome, social, all these variables. So we want to find the function that maps all these variables here to the target variable. How, what makes a client a yes and what makes a client a no. And we want to learn one function that maps all the 41188. I mean, is it clear?
Yes, that is clear. Now, the other question is about that statement itself. Like, has the client subscribed to a term deposit? I just don't know the content about that statement.
So, the problem statement, or the problem that this bank is struggling with, is they want to know if a client will subscribe into let's say a loan, a student loan. Okay, so the bank wants to determine if you will be if you'll be applying for a student loan or you won't be applying for a student loan. Okay, so they went through, they have 41,000 clients in their systems. They went through them. This has happened a long time ago, and they labeled them one at a time. So we have Amin in the records, and did Amin have a student loan? Yes or no? No. Then we are gonna put no for Amin. Jasmine, yes. Idris, no, and it goes all the way up to 41,000. This is how we come up with the target variable. A target variable is simply labeling our 41,188 clients we have in the system as either they had, this is in the, they had a term deposit, or they don't have a term deposit. And this is what we find out. 12% of our 41,188, they do actually have a term deposit. 88, they don't have the term deposit. So this is what we have in data. So, and we want to map all the input to this target variable. We want to find, in other words, in a very plain English, English, we're trying to find what drives a client to have a no, and what is the mathematical influence that drives a client to have a no as a label, or drive a client to have a yes as a label. And once we determine that mathematical influence, of course, if you are a new client, you just signed up for our services, we are going to apply that mathematical influence on you, and it is going to tell us this person will be yes in the future, or this person will not be, will be no. And based on that, we can definitely treat you accordingly.
So yes, data wise,
Yeah,
I got it.
I mean, before we proceed, is it clear?
Yes, it's clear. I'm just I want to know what the term deposit signifies,
So term deposit, in our example here, is we might need to have some expert from a bank, but simply is a term deposit. It could be. Do we have any expert in banking here, in finance? Term deposit, I would simply, it's simply
relationship where they actually park their money with the bank for a term that is determined, and they get an interest at the end of the term. That's the term deposit.
Yes, thank you. Yes. So in other words, so you open an account with the bank. You have 500,000. And are you allowing the bank to utilize the money for investment in a return of an interest? So some of the you could have your money and you simply don't want the bank to use it. Simply you're saving your money with them. So they want to know that if you open an account, you would allow them to invest your money, and of course you are going to get your share. And it's a very small share 0.01% or something like that. So that is for, in our case, that is what term deposit. I mean, is it clear?
Okay, yes. And is this term deposit subscription, is it with the insurance company itself or with a third party or an external bank?
No, this is with the bank. This is a bank problem. So you really need, I think you are, data. So we are going to move into data visualization. And yeah, before we touch base visualization in general, let me explain a few things. So data visualization happens at 3 levels of your entire project. So data visualization, you should apply data visualization at 3 phases of your entire project. So you should apply data visualization at the during the data understanding. So you should apply data visualization. This data visualization here will help you understand the quality of your data. Okay, that is very important. Data visualization at the data understanding. So there are three phases, or three part, or three times you should apply data visualization in general, in three ways. So the first time we apply data visualization is simply try, help us understand the quality of the data. And also we could apply data visualization on the modeling to help us understand how decision was made. These models here will make a decision on whether when the model trying to create the function to map the input to the output, it makes some decision boundaries, and we want to visualize them. And if we were to look into, let's Google it. I'll give you an example. Okay, model decision boundaries. Yeah, so this is an example. Yeah, so this is a boundary. This is how the model makes a decision to to differentiate, or the no's from yes. So the red is yes, probably the blue they are no, and of course there are a lot of errors in there. So this is another decision. This is a lot of decisions made, and every model has its own way to make this type of boundaries decisions. Some of them they are linear. Some of them they are non-linear. So this is non-linear. This is non-linear. Some of them they are linear. So yes, and yeah, we are going to learn some of this later in the program. So these are linear. So they're making a linear decision. This one is linear. This one is linear. This is a decision tree, non-linear. So that is how we we apply data visualization to help us understand how these models are making decisions. And finally, we are going to do we are going to apply data visualization to present. So if we were to present to the stakeholders and management, of course, we don't need to explain to them how we conducted analytics using the Jupyter Notebook or Python. Most of they really don't care of your codes. All what they care about is give me an insight, give me a tested action plan, insight that I can build my decisions upon. So we are going to present to the stakeholders and try and probably using the PowerPoint where we should include all our findings, some screenshots of some of the finding and share with the management. So that is the three method or three ways or three times that you need to apply data visualization. So we apply data visualization during data understanding to help us understand the quality of the data. We will try to apply data visualization on the modeling decisions, simply to help us understand how the decision was made. And finally, if we were to present to the stakeholders, we need to design a better communication. You could be a very good data scientist. You went through smoothly everywhere, through the workflow from business understanding all the way to deployment. But if you are unable to interpret and explain your finding to the stakeholders, I don't think they will believe you. You are going to have a very serious problem selling your output to them. So that is the three methods where you need to apply the data visualization. Of course, we are going to learn a lot about data visualization during data understanding. And when we are talking about data understanding, data visualization, basically there is a lot of graphs, a lot of plots that you could create. So here is a website. It has most of the functions, most of the graphs. I'm going to share it with you guys in the chat. So click, just use this as a reference. Click on the one that you think could simply help you understand or meet your requirement. So it has a lot of description. Now the description, this is a density plot, what it does. And yes, and there is a video explaining the concept. But in general, as an analyst, and of course it depends on the type of the data you are working on, but in general, you are going to need 6, 7, 8 different plots. So number one, you are going to need a bar plot. And this bar plot is used to visualize categorical data. Okay, and number two, you are going to need a histogram, which is used to visualize the numerical data. Number three, we are going to need a box plot, which is used to visualize the 5-number summary of the data. 5-number summary is the mean, max, quartiles. Okay, a scar plot is used to visualize the magnitude of a relationship excuse me, a relationship between 2 plus independent numerical variables. And we got here number 5, line plot, which is used in time series. And number 6, density plot. which is used for numerical, also numerical values, variables. And number seven, heat map, which is used to visualize the correlation. And finally, maybe a violin plot. Plot, which is simply combining the density plot plus box plot. So these are some of the most common plots or graphs that you need to master, and others depends on the data that you are working on. Okay, so bar plot is used for categorical data. So please go through that, educate yourself on what it does, learn it, speak the language, Google some big words if you don't understand them. So that is bar plot. Box plot is used to visualize the 5-number summary. So we got the whiskers, lower whiskers, upper whiskers. We have here upper quartile 75%, 50%, 25%, the 5-number summary, and of course we got bubble density plot. We talk about it, and we got here histogram. So histogram is used for to visualize the numerical data. And what else? We got scatter plot is used to visualize the relationship between two independent variables, and it does simply help us understand the magnitude of relationship between two independent variables and the direction of that relationship. So linear, nonlinear, scattered. This is a positive relationship between x and y. This is negative relationship, and this is a this is a null. There is no influence between them. Okay, what else? We got scatter plot, and we got violin, and where is line plot? Yeah, line plot, which is used in time series. So these are the most common graphs that you need to be familiar with to help you understand the values or the quality of your data. So let's take a look. We are gonna start doing some data visualization, and of course with data visualization we are talking about univariate, bivariate, and multivariate, and we are talking about the relationship between categorical and itself, numerical and itself, numerical and other numericals, categorical and numerical, etc. There's a lot of relationship we are trying to determine in here. So let's take a look into the features. So, and the first thing we gotta do here is we are gonna build a histogram. And because histogram is mainly used for numerical data, we are gonna create a group, or we are gonna create a new feature. Simply, we are gonna create an object, and we are gonna assign to it all our numerical values. Age is numeric, and duration is numeric, and we are going to use a histogram. We are going to use a histogram on this animal here. Let's take a look, and the size is going to be 20 by 20. So of course it's going to build a histogram on age, histogram and duration, histogram and campaign, paydays, etc. Let's take a look. So the age, let's take a look into the age. So what we are exactly looking for when we're trying to visualize data during data visualization phase is trying to determine if there is any problem with the data. And what we are looking for, we are looking for any sign of a poor quality. So of course, the best data is a data. The best data is a data with normal distribution, something that's normally distributed. So looking into this data here, we see that we have some problems. We have some outliers all the way to the end. If we were to move, if we were to move this, if we were to move them, we don't know yet if we should remove them or not. But if we were to move them, probably we are going to get a bell-shaped, normally distributed data. So age has a problem that we need to determine. The duration, we got a lot of zeros. Why the zeros here? So let's take a look into data one more time. Why do we have a lot of zeros in duration? So what is the duration first? Let's educate ourselves on that. Yeah, last contact duration in second. Yeah, in seconds. So this is an important note. This attribute highly affects the output target. If duration is 0, then no. Yet the duration is not shown before a call is performed. Also, after the end of the call, Y is obviously shown. Thus, this input should only be included for benchmark purpose and should be discarded if the intention is to have a realistic predictive model. So we need to consult with our team to help us understand what is exactly the duration is. No, this is not enough information, but it looks like the duration has a high effect, direct effect to determine if a client will be term deposit or non-term deposit. So, but we have a lot of zeros. We have a lot of zeros in the duration. A lot of zeros, as you see here, and we have a lot of outliers. We have few outliers in there. So this is an outlier, and we have some outliers there. So what is an outlier? An outlier is simply a variable that lives outside the majority. Let's say that we have a column called age. We got a column called age, and we got some values in there. Okay, so we have age here. We got 19, 21, 40, 62, 34, 1, 21, and we got here 17, and we got 40, and we got 19. Okay, so when you plot this data into 2D, we got age here. Sorry, we got for age, and we get here the count. So if you were to plot this into 3D, you are going to see something like this, for example. So you got 19, 21, 40, 34, 17, 40, 19, so you got 1, 2, 3, 4, 62, and we got here 121. This is your 121. So this is the majority, and distance-wise, this 21 lives too far too far from the majority. So this is a problem. Yeah, we have a problem here. So of course we need to determine what needs to be done. This is called an outlier. An outlier is simply, statistically speaking, an outlier is in any an outlier is in any element that is at least 2 standard deviation far from the mean. So if we were to plot so yeah, this is standard deviation number 1 and this is number 2. So any animal that lives 2 standard deviation from the mean is considered an outlier. And these outliers could create a lot of statistical problem in terms of GIGO. So we have to handle this. We have to figure out how to handle them, which we are going to cover later. So that is what, and this outlier, it could be very small. Let's say that we have another column here, or another client with 7 or 5. So we got some here. So this is an outlier too. It's too far from the majority. So an outlier, it could be high, the highest or the highest unique value, or it could be small, So we got some problems with the duration, the campaign. We got some problems. Paydays, we got unbalanced. So the cons price, we got really some missing value. I mean, there's no missing values. I think there is some problems in there. We got an outlier. We got problems with some there also. So we got a lot of problems in between. So this histogram simply provides a clear picture of the quality of your variables, your numerical variables. So I can tell a lot of work that we have to do to transform this data into a better shape. So that is what histograms could do. Very simple histograms, as I said, used for numerical data. Density, density will provide the same information, but it's the same information that you are going to get, but it does show you better, a clear picture. It simply will pinpoint to the exact location of a problem. I always do.
Brother Mo?
Yes, sir.
I have a quick question.
Yes, sir.
In the plots, you define the features, but how do you get these numbers on the left-hand side? 200, 400, 600, 800. How does it pick up that information?
Yeah, that's a good question. I think this is these are the number of we got 41,888. That is the count. Okay, so this is the count. For this is univariate. Uni means one variable, and they have different scales. So these scales here, they are simply representing the values, the number of values that we have in our data, from 1 to 41,188. But this is all what they represent. And of course, you are going to get them. Some of them they have but they have different scaling. It's different scaling.
Yeah. They are adding up to 41,188.
Yes, but it's 41,188. And the bottom values. This is the minimum and the maximum. Like for example, the age, we got the minimum. the minimum of age is
Yeah. Yes. That comes from features.
yes, the minimum is 17 and the maximum is 98. So the minimum is 17 here, 20 is 17, and the maximum is around 90, 98. You see that? There's one animal here. You know, it's very very tiny because it's an outlier. You don't see it. Okay, unfortunately, let me see if I can change this. 30 by 30.
And brother, for the age, it doesn't go to like 41,000 in like individuals. It only goes up to like 12,000. So
That is
is it not considered?
that is I mean it's that's why I said it's different scaling, but it goes from the zero and column zero, row zero to all the way to 41,000. Yeah, different scaling. I don't really know why we should have the same scale, but for a reason it provide it displays different scales. I have to figure out why it's doing that.
Brother Mel, I think I know why it's doing that. It's a cumulative effect. So if you add like for the age 20, you add 2,000. For age 30, you add like close to 12,000. Age 40, and you keep adding all of them individually, they'll add up to 41,000 records.
It could be, yeah. I really don't know, but thank you so much for the input. Okay, yeah, it's still too small. Yeah, we might need to change the size again. But for the density, yeah, like for the age, so this is the age. No, this is yeah, this is the age. So we got some problems at the beginning. We got some problems at the end. And our data has been positions between somewhere in the middle. The duration we got high peak for the zeros, and the remaining is all. So we got a lot of zeros. A lot of clients they have zeros, and majority they have a value different than zeros. So that is very simple density plot. It shows us exactly where to look into as far as these problems that we discovered using the histogram. Okay, I believe this is yeah, this one we are combining the density and we are combining density plot and histogram.
Brother Mo, just quick question. In terms of library, so by default it's matplot, but then you can, if you want to see more fancy,
it's not by
no?
You have to import
The Seaborn.
yeah, the Seaborn. No, the matplotlib. You have to import the yes. So this is the most common one. When you import matplotlib, no, it's matplotlib. But if you were to borrow the beauty of the Seaborn, simply import the Seaborn and set it. Use the set function method. So
what should be our preference? And just to be consistent, do we need both of them or one is enough?
Yeah, one is enough. The matplotlib is enough, but there's a lot of beauty. The Seaborn is more. In terms of the graphs designed or created by Seaborn, they are more beautiful.
Visualization, okay.
Yeah, when it comes to visualization, yes, there are a lot of beauty behind them. So you still can use the matplotlib, matplotlib codes, and if you were to borrow something from the Seaborn, simply do the SNS or Seaborn set. You need to set the Seaborn as the default. So Seaborn is built on the top of matplotlib. You really don't need to code a Seaborn. simply use the matplotlib, and you'll be able to borrow some functionalities from the Seaboard. Okay. And for this,
Brother Mo, one quick question.
yeah, please hold on. I mean, the Seaboard. So I believe I shared this with you guys in the past. So let me share it one more time. So there's a lot of examples. Just look into the one, like line plot, scatter plot, histogram. Yeah, this is a stacked histograms. All we have to do is copy paste, copy the codes, and paste it into your Jupyter notebook. Run it and start changing the variable. Start changing the putting your own data. So this is designed on simulated data. Simply replace your this simulated data with your own data. You should build something similar to this. Yes, Amin?
Yeah, this is a quick question, and I know you might have covered this. So all these packages, where do they get imported from?
They are these are packages that been they are in cloud. Okay, so they've been stored in the repository in cloud, so they've been imported them. And the package is simply a collections of tested codes. They are doing specific things. So you import if you want to do some arithmetic. You import NumPy. If you want to do some analysis, you import the pandas from the cloud to your local Jupyter notebook, to your local system. Some of these packages you need to install them in your system. And let's take for example scikit-learn. So yeah, this is a package, scikit-learn. So if you were to do, for example, classification, you are going to import from this website. You are going to import, let's say, feature selection. Import from scikit-learn from this website. Give me feature selections. Method. Import a data set. Import a Gaussian process. Import ensemble method. Import. So the import here is from the cloud, from the repository where this package has been stored in the cloud. And as I said, some of the packages you need to install them in your local systems. I mean,
Okay, brother, thank you.
So now we are combining the density plot with the histogram of the age. Yeah, we still we see clearly where the problem lies. So we got some high values in there. There could be the outliers. So, and we got some low values. There could be an outliers also. So we got some high values in here and some values in there. So really we need to determine what's going on here. So that is so anyway, these graphs that we are designing, they are helping us understand our data piece by piece. Why we need to do that? To avoid the GIGO concept. So to avoid the garbage in, garbage out. So of course we want to build a model, we want to build a solution that is not biased to anything. Okay, so frequency bar plot. So now let's do a bar plot, and let's take a look into all the feature, all the non-numeric, jobs.
Hello, Bramo.
Yes, Idris.
Yeah, I want to thank you so much for the wonderful job you're doing. Yeah. I have a very simple question. I want to ask, from your experience, if you have a data that is skewed, that have an outlier, and you really see that the outlier, of course, is going to have a very large impact on the range. So do you, for the sake of data cleansing at times, just remove maybe like 0.001% outlier that seems to make the data biased, just like you just said now, or you just try to struggle to really know the problem of that very few negligible outlier. All those negligible outlier can actually be what is going to give us insight to cracking the problem. So what's your experience like in this area?
Yeah, I really, I did not get your question correctly, to be honest with you. But the outliers, we are going to cover them later. Right now, I don't want you to worry about how to handle outliers or any missing values or any data quality problem. Or what we have to learn is how to detect this type of problems at this point of time. Don't worry about how to handle them. We are going to cover it later.
Oh, thank you. Thanks so much. I appreciate it.
Did I address your concern, sir?
Yes, boss. That's perfect. Thank you, sir.
Thank you. Thank you. Good. So let's. So we did the histogram on numerical data. We know that we have some problems in there that we need to fix. We have some outliers. We have some probably higher outliers, small outliers. So we need to handle later, and of course we are going to learn how to do that, in the program. Now let's do a bar plot. A bar plot is used to visualize the non-numerical. So job is non-numerical. We got 12 unique variables. Top is admin, and we got admin is 10,422 admin jobs out of the 41,1888. So let's apply that. So we are going to compare them. Yeah. So now we are comparing. We are going to compare day of the week, model. So take a look. So this is a lot of insight in here, a lot of information. I would say a lot of information. So we are comparing. Sorry, guys. So we are comparing. Yeah, we are looking into day of the week, marital status, previous outcome, and the default. Day of the week, I think, we have almost a balance, Monday to Friday. Of course, there is no weekend because this is a bank. Banks, they don't open on the weekends, so it doesn't make sense unless if you see a Sunday there or Saturday, then you have to figure out. You have to clear out doubt about that 1 day or 2 days with your team. And the marital, we got most of our clients, they are married, they are singles, some of them they are divorced, and we have a small minority of unknown. So this is an outlier. This is an outlier. Okay. And what to do with this outlier is something that we are going to determine later. For the previous outcome, we got non-existent, failed, success. So we got unbalance. We got a lot of non-existence. It could be an outlier. So we might need to determine what to do with it. And the default, we got a no and yes. We got a yes as a very, very tiny part or portion. So this is an outlier also. And we got an unknown. So we need to determine what to do with unknown. Do we need to label it as yes or label it as no, or keep it as is? So here we go. So now we are building our understanding on the data, and you should document this. And I'm talking here about the best practice. Sometimes you really don't need to go through this. Once you are an experienced person, of course, you really don't need to go through this. Okay, now comparing the housing, the loan, the contact, and the month. Let's take a look. So the housing, do you have a house, or are you renting, or are you owning a house? That could help to determine if you'll be term deposit or non-term deposit. So out of the 41,188, we got the majority is yes and no, but unknown. So this is an outlier. Yeah, we have to handle it. So we have to handle it. We could simply add outliers to the mode. So we are going to add outliers to the yes. And for the loan, yes, no, and unknown, this is an outlier also. For the telephone, the contact, how to contact is I think this is a landline, and this is a cell phone. But landline, they are gone, they are dead, and they expired. So we might need to figure out if there is something that we can fix for these clients. Month, we have the highest, the highest month showing here is May. So we need to figure out why do we have a larger. Is this because of peak season? There must be a reason behind this. Why we have higher, it's high in month versus December, for example, and March, October. So probably this might be a high season. It could be an outlier. It could be an outlier. It could be an outlier also. So there is a lot of information that we got through these graphs, and a lot of works need to be done if we were to determine, if we were to use them. So a lot of work. But this is how you build your own the quality report. This is how you build it. So simply document everything that you know about your data as at this point of time. Okay, let's take a look into the jobs. Here we go. So these are, and you could do this. You could do one at a time. And you could do one at a time. Let's create one and months. Let's do the months here. Is it with S? No, without S. Is a month, not months. Here we go. So now combining, comparing the jobs levels. So this is levels. It's categorical. It's called levels. So the majority is an admin, and of course we already know that. So when we looked into the describe for your non-numeric, we already have that piece of information. So for the job, we got admin, and admin appears 10,422 out of 41,1888, and the graph confirms that. We got an unknown. Yeah, we need to figure out what to do with unknown. We could keep it. We could simply consider it as an outlier. But now, we got a lot of admin, blue collar. We got few students in there, housemaid in there, management, retired, etc. So this is another graph for the month. As you see, we got a very an outlier in there in December. Compared to May, it's an outlier. So we need to figure out what to do about it. Education, let's take a look. So we got a lot of university degrees clients. Actually, we got some an outlier in there, an unknown. We don't have any information. So here we go. So now we are start building our understanding of the quality of the data. We are building the understanding step by step, and this is how we build our quality book. So this all should be documented in the quality book. So do that. Please go ahead and that is your homework. I assigned 2 homeworks for you. Number 1, please go through the pandas library, educate yourself, and number 2, please go ahead and document, run this up to let's do one more things here. I think up to Yeah, up to multivariate visualization, and documents your finding. And try to play around it, just play around it and see if you can see anything meaningful. So any questions, any concerns about this?
Is this called data scrubbing, or what are we?
Data scraping is getting the data out of the website.
Okay, so this is just visualization.
Data viz. It's called data viz, VIZ for short.
Okay.
Okay, and when we are talking, as I said, about the data visualization, it's done in three parts of your entire project: during data understanding, during modeling, and the presentation. And the data visualization can be univariate, multivariate, and bivariate, and it could be data visualization between categorical and categorical, categorical and itself, categorical and numeric, numeric and itself, numeric and numeric. There is a lot of combination that you could apply your data viz to help you understand your data better. Okay, so data visualization during the data understanding can be is used for two purposes. It's used to help you understand the quality of your data, number one. Number two is used to help you get some insight. Yeah, get some insight. Data visualization is used to help you understand the quality of your data, and also it's used for descriptive analytics. Okay, folks, it's 6 minutes left. Let's stop here for the moment, and let's open the floor for you guys to see if you have any question, any concern, any doubt that I'd be happy to address.
Hi, Brother Mo. This all data coming from one file, bank loan CSV full that file, or there is a different other CSV there? So it's coming from different file.
It's the same file that we used in the previous sessions.
And if we want to later on use own file, so we can put their file right on the same path and can try.
Yes, but yes, we are building a template that we can use for your own data, but just make sure that you change the variables. Okay.
Yeah.
Age. You might not have an age in your data. You might not have a marital status. You might not have an education. So make sure that you change the variables when you are trying to apply this template on your data.
Got it. Thank you.
You're welcome. Any questions, concerns, everybody? Okay, just as a matter of fact, we might not have a session next week. It's so we want to make sure that everybody is spending the time with the families. So we are going to skip to next week, next weekend. No class on Saturdays or Sundays. Okay, folks, that's it for today. I'll talk to you tomorrow. Until then, you guys have a great evening and the rest of the week. And bye, everybody.
Thank you, Mo. Thank you.
Thank you. Tomorrow time.
Thank you, Brother Mo. Thank you.
What is tomorrow class time?
10 a.m.
10 a.m. Okay, thank you.
Yeah.
Thank you so much. Thank you. Bye-bye.
Thank you. Bye-bye.